Hi guys, welcome to Linkside YouTube channel. My name is Ram Mishra and I'm your online instructor. So what's in this video? In this video we will talk about Kubernetes deployments. But before start the lab session we need to understand few points, which is what is Kubernetes deployments and the use cases. So as per the Kubernetes documentation, Kubernetes deployment tells us Kubernetes how to create or modify instance of the pods that hold containerization application. It is high level resource object by which you can manage the deployment and scaling of the applications while maintaining the desired state of the application. You can scale the containers with the help of Kubernetes deployment up and down depending on the incoming traffic. If you have performed any rolling updates with the help of deployment, and after some time if you find any bugs in it, then you can perform rollback also. So this is the very big plus point with the Kubernetes deployment. So in short we can say it is a management tool for controlling the behavior of pods. So in this demo we will see that how we can work with the deployment in Kubernetes cluster. This is the official documentation. You can go over there and find out the use cases and number thing, including the files, right? Deployment file. So let's move to the lab session. I'm back on my virtual machine. Here you can see currently I'm working on a single Linux machine where I have already installed Minikube single node Kubernetes cluster. Let me show you the OS release version of this machine and then the Minikube status. So if I start with cat etc red hat release, this is 9.3, and if I go with Minikube status, see it's running perfect. Now before moving to the next, we need to verify the status of cluster. To check the node availability in the cluster, we can go with kubectl get nodes command. So here you can see my Minikube node is ready, and once you have node available in your cluster, you are ready to create your pods. So now we will check the pod status. So command is kubectl get pods, no resource found in the default namespace. Since will be our first pod in the cluster, so you will not see any pod in the default namespace. Let's check the service availability also. So service we can check using kubectl get svc. So here you can see one default cluster IP service is running in the default namespace for Kubernetes cluster on port 443, and I don't have any node pod service running on this cluster for exposing my application to the external client. So let's move to the first tab, which is launch our pod using deployment in Kubernetes cluster. So let's create a file in a dedicated directory. I'll move to my k8s directory. Currently I don't have any file here, and let me make a file deploy.yaml. Name could be anything, or code could be based on JSON or YAML format. So deployment pod creation code is available on the Kubernetes documentation. You can grab it from there. Let me show you where it is. So if I go back on the documentation, here's the entire code. This is the entire code. So from here you can copy it. I have already copied the code and modify as per my scenario. So let me copy the code from my notepad and paste it here, and then I will explain. So I'm started with my deployment file. Let me copy here, paste it. Yep. Now I try to explain one by one. Let's break each line that was used to create our deployment. Start with the API version first, right? What is the API version? So API version which is specify the Kubernetes API version. In this case it is using the apps/version 1, the API version which is the appropriate for deployment. Kind specify the type of Kubernetes resources. Here it is a deployment, indicating that this configuration file is defining a deployment. Metadata provides metadata for the deployment, including the name, labels, and annotation. So this is my deployment name, and I just have mentioned I'm using the first app version, right? And then we can mention few more things here. Then we have the specification, define the desired state of the deployment, including the number of replicas, the pod, template, and any other related specification. So it's include few more items like replica. Replica says specify the desired number of the identical pod replicas to run. Like 3. Here I have 3. 3 means we want to run 3 replicas of our application. Selector is very important, right? So selector specify the label that the replica set used to select the pod it should manage, right? Match label specify the label that the replica set create the deployment should use to select the pod it's managed. In this case pod with the label team Linux are selected, so I just mentioned the label team Linux. Then I'll go with the template. Template field contains the pod template used for creating new pod, including container specification, image name, and container ports. Then we have a metadata. contains the label to apply the pods created from this template. In this case, the pod will have the label team Linux. Then we have the specification. Inside the specification, describe the specification of the pods. So just like container, this section define the containers to run in the pod. Then we have image, what image you are using, so specify the Docker image to use for the container. Here I am using my own custom Docker image, which is publicly available on hub.docker.com, and that is Ram Mishra /demo01, right? And the name, I have mentioned the name, container name, this is first container, and ports, define the ports to open in the container, and container port is 80, that indicate the container will listen on the port 80. So this is line by line I have explained here. So in short, this deployment file will create a Kubernetes deployment named first deploy with 3 replica, and each running a pod based on the specified call custom container images and pod configuration. And the pod will be labeled with the team Linux, and they will be managed by the deployment. Now my deployment file is ready, time to deploy using kubectl apply command. So let me save and quit. From there I will go with kubectl apply-f deploy.yaml file. Okay, it's created successfully. So here you can see we get the message, it's successfully done. Let's check the kubectl command and check the this deployment. So command is kubectl get this, or we can go with first of all, okay, let's go with the describe first. describe describe, but we need to get the port first, right? So kubectl get ports, okay, and then we need to get deploy. Okay, here we have the deployment name first deploy, right? So here you can see deployment successfully done, 3 by 3 replica set is ready. Now let's describe your deployment using kubectl describe command. So I'll go with kubectl describe the deployment, deployment deployment, and my deployment name is first deploy, right? Let it be go. Okay, I am getting warning replica set create error. Okay, failed to deploy the replica set. Let me delete this one and create one more time. So I'll go back, replace apply with delete, delete, and let me go one more time with apply. Hopefully everything is good. Yeah, here it is. So now here you can see deployment name. If I go scroll up, here we have a deployment name, that is the first deploy, then the annotation, then we have a selector team Linux, then we have replica, 3 desired, 3 update, and 3 is available. Strategy is rolling update strategy. Okay, and this is okay for our own requirement, right? Now let's check the replica set status also. So we have the command kubectl, we go back kubectl get get replica set. Okay, similarly we can go with pods -- show labels. So okay, everything is okay. So all pods are up and running condition, replica set is ready. Now move to the next part, which is exposing the replica set. Now we have created a deployment and need to verify if the web server deployed properly or not, or is working or not. To straightforward, we need to achieve this is to create a service object that expose the deployment. An important fact to note here is that the way we expose the deployment and the parameters can vary depending on the configuration of Kubernetes cluster. So I'm going to create a not pod service which is used for expose my application to outside from the cluster. So let me make a service.yaml file and let me copy the code from my notepad one more time. So here is the code. Okay, let me copy and paste. Okay, so this code is also available in Kubernetes documentation as node port service. This YAML file defines a Kubernetes service object of type node port. The selector block instructs the node port service to send incoming traffic to one of the ports with this label. Here it is Team Linux. And the node port section, this one, if you talk about the node port here, the node port tells Kubernetes which port to open to the outside world on all of the worker node. This field tells Kubernetes to expose this service on port 32,000 on every node in the cluster. Then we have a port specify the port that should be open to the cluster internally, not externally. Incoming connections will be accepted on this port only if they can come from within this cluster. External connection won't be accepted on this port. This is in our case 8181, and the final is the target port. So target port, this service will forward incoming connection to one of the ports it exposed. Target port specify on which port of the port to send traffic, which this config, even if traffic comes to port 32000 on the node, it will be sent to the port 80 of the port, that is my target port, right? And finally I have selected the selector field. Specify a label selector that defines which port should be exposed by this service. In this example, the service will expose all ports that have the label team Linux. Now let me deploy this service, and then we will check the status using kubectl get svc command, right? So I'll save it, kubectl apply -f service.yaml, and one more time kubectl get svc. Okay, so here you can see new service name backend is ready with the node port type and running on node port 32000, right? Let's get the public IP of my Kubernetes node, and then we will hit on that IP, right? So kubectl get nodes -o white. Okay, here it is, the IP address. So I hit from here Firefox. Let me try to copy and paste it. On hit, the port number is 3200 and go with the backend. So if everything is okay, I set it on this IP, the node IP, with the node port 32000, and if within a few minutes we will see the first version of my custom web server. Okay, yeah, here it is. This is the first version of my custom web server. Perfect, it's working. Now move to the next tab, which is update and rollback Kubernetes deployment. Let's assume that we need to change the image server version from 01 to 02 in our deployment for better performance. Then we can do this by two methods. Either we can use kubectl set image command, or we can go and change in the deployment configuration file. If we go with the first method, which is kubectl set image command, it can be used with the container name of the template and the required image name to update the ports. Let me show you the command I have mentioned in my notepad. Here, this is the command kubectl set image deployment, your deployment name, your container name, and the image, the updated image what you want, and then I use -- record here. So -- record flag to save the command for further purpose. Theoretically -- record is not mandatory, but practically it is mandatory in order to ensure the changes leave a basic audit trail behind the DevOps culture. So if you use this command, it will update the image of the current deployment to the demo 02 version, right? As soon as we press enter, we will get the rollout status if we run the get rollout status command immediately. But in this demo, I'll go with the second method, which is changing the deployment configuration file. So we can open and edit the configuration file again and navigate the relevant sections like container images and replicas, make necessary changes, and we can even scale up, scale down replica also. So let's do it. I'll go back on my VM one more time. I'll open my deployment file. Let me update annotation first. Hey, this time I want to go with the second app version. Let me update the replica. Earlier it is only 3 pod I needed, now I needed 6 pod, right? And what I want, the image is not 01, it's 02. Okay, perfect. So here I update annotation, replica set, and image version. So let me deploy one more time the same command, kubectl apply -f deploy.yaml. So as soon as I press enter, if I try to hit, let me see what happened if I try to enter. Okay, see deployment.apps first deploy configure. Now if I try to hit the browser one more time, then we will get the updated one, and earlier that is the first version of the custom web server. Let me hit. Okay, it's taking time. Let me check the pod status. kubectl get pods -get pods. Yeah, see, earlier there is only 3 pod, now the 6 pod. So if I try to refresh, yeah, earlier there is the first version, now this is the final version. So we will get the update one, right? So even if we check the pod, we will get the 6 pod, right? Because we have updated in the config file. So replica number is also increases automatically here from once I deployed that one, right? But think about the scenario. Let me roll out this deployment. Think about the scenario: current deployment image accidentally updated to the latest version, which was not fit for the customer point of view. They want rollback again. So first of all, we will check the deployment history using the following command, which is the command is rollout history. You can check it from here. This one, kubectl rollout history deployment first deploy, right? So if I go and press paste here, yeah, here you can see that. Here output give us a revision column and change case column. Whenever there is a new change to the same deployment resource, the controller increments the revision value by 1, and beside that the change case column is a column that display the Kubernetes change case or notation on our application. So let me roll back to the first version. Now if you want to back in the undo condition from here, either go or modify the deploy file one more time and then deploy, just like we have few minutes ago we have done that, or we can use kubectl rollout undo command. So let me go with the undo command. Currently if I'm trying to refresh, you will see I'm getting the final version response, right? That is the updated one. So I want to go back on my first version. So how I can do it from here? So the command is very simple command from here. Let it be copy. Command is kubectl rollout undo to revision. Which revision number? So I want to go in the back one first. So let me set the number here. Let replace from here 1. The deployment name, my test deployment. Then which deployment? The first deployment. This is my deployment name, right? Now as soon as I press enter, it will be roll back on the first version, and we can check the rollout status also. So we have the command kubectl rollout status. Okay, so let me press enter. Okay, it's rolled back, and now let me check the rollback status. See, it's finishing up. Look at that, it's going to be roll out. Yeah, deployment first deploy successfully roll out. So now if I try to hit again on the browser, we will get to the lower app version output, right? See, earlier that is the final version. Let me try to refresh. See, I got the first version back. So this is how what we can do. We can roll out the deployment using these command, right? So if I go back history again, see, it's changed. Now the first one is the latest one and the second one is the second one, right? So this is how you can use the rollout functionality from the Kubernetes deployment. Move to the last part, which is delete the deployment. So you can also use the same file that used to create the resources and possibly other resources definition as well to delete all the resources by simple running kubectl delete delete -f. Let me delete the deployment file as well as the service file. Okay, so now what happened? The above command will delete the deployment, replica set, all ports that is managed as well as the node port service. So let me check one more time before moving next. Kubectl first of all, let's check the deployment. Get deploy deploy, no, perfect. Pods, no. Replica set, no. And svc node port service gone. So all entry gone. I'm back on my default condition. So guys, that's all about the deployment, how we can take the deployment, how we can go with the rollback functionality. So you can take more important informations and the example from this official documentation from Kubernetes. So that's all. Hopefully you enjoyed learn new things. Soon I will come up with another new interesting topic. Till then, keep practicing. If you feel something I have missed or you wanted to know more something else, please reach out through my social media links, which is mentioned in the description. If you like this video, please do not forget to like, share and subscribe my channel and press the bell icon button for the latest update. Thanks for watching. Stay safe and goodbye.